at CH2 generation. We look at rainwater harvesting, different locations, surface area, coefficients. And then we look at the graphical analysis of what's happening actually. How do you match your consumption? So if you look at this curve, this is like the demand, so these are the months of the year. The demand, which like for heating demand is usually decreasing in the summer. You know that with your biomass you can achieve this amount. With ground source heat pump you can achieve this amount of heating. And with solar water heating you can achieve this amount. So now you can actually start to look at, okay, I can probably have 2 ground source heat pump system to achieve my 80% target. Or I can actually have 1 biomass to get my 60% target. And you compare the price of 1 biomass against 2 ground source. And we've got some monthly graphical analysis for the cooling. So again, you look at your cooling demand, it increases in the summer, and you look at your tree generation, your ground source heat pump demand. And you try to look at what is the best combination you can get. And then we've got electrical demands, similar with photovoltaic, with wind turbine, and with electrical by having both of them. And you look at also water demand, which is actually much easier, and you can try to match it with the rainwater harvesting. And as a result, you can have daily or hourly curves, looking at the profiles every 10 minutes, every hour, and you can know exactly when you're going to need to apply more energy. And then we look at the best combination assessment. So this look at just the basic rule of probability, where you've got your number of technologies available, your group size, you want to know how many technologies you want to integrate, and you want to know like the number of technologies you've got. For example, if you've got 4 technologies, which are like A, B, C, D, and you want okay, so you want 2 technology at a time, you're going to have the equation as follow, and you get 6 combinations possible. So now imagine you're going to have, I don't know, 8 technologies, 10 technologies, you probably have 3 million different options that you have to select. This is just a basic rule I've done. I wanted to check how many combinations you can get if you got 30 technologies different. You get something like 8 to the power 13. So you look at when you're inside a project and you have to make a decision with your clients, and you have an hour, you have to select one option out of 1 and 8 to the power of 13 solutions. So what can you do? So what you do at the beginning is you pre-select with your customer. You look at, you really need to make sure that you got the right option. So you're going to forget about some ridiculous ideas and some pre-concept ideas that you probably don't want to integrate into your building. And you keep it as simple as possible. So for a group size of 3, where you want 3 technologies at a time, and you've got 4 technologies that you want to select from. So AS, I'm going to show it. ASGT, which is like passive solar air, solar water heat, group ground source, and tree generation. This tool actually tells you that you got 4 different options, different combinations. And out of this, this is the result for each combination. So on energy, you'll be able to generate 600 units. On CO2, 900. On cost, you probably have 800. So if your project is cost-driven, you'll select probably the 700, so solar, ground source, and tree. Or if your project is cost-driven, is CO2 saving-driven, you'll probably select the first option. These are the different results. These are the different data for each technology. This is a bit of like a facade of the tool, how it looks like. It looks at where you are in the world, how much energy you need, and how much energy you can generate. For example, in Edinburgh, it needs lots of sun, but you haven't got too much sun, so it will be at the bottom. But Cardiff, you probably need less sun, and you'll be at the top. This can be also, again, done for every different type of resources. And then we've got the building cogeneration energy concept, looking at all these technologies and how do you actually manage them and to integrate them into your building. So you want to, this is like the classical design that you've probably done on every project, and then you want to integrate all these innovative technologies without compromising the use of the old ones. This is your heating system, cooling system, and your thermal active slabs. And this is me. If you've got any questions, there's some time. Hope you enjoyed it. Thank you for coming.
Thank you for your Are there any questions? If you please take the microphone and introduce yourself.
Stuart Martin from University of South Australia. I just wondered if you have an example of the combinations that you've chosen for a particular building, or is it still just a simulation package? That's one question. The second one is, are you aware of any tri-generation systems that you've installed or are installed in Scotland, and how effective have they been?
Yeah, there are hundreds of case studies all around the world. I don't have them here, but I can talk to you later on. They are already installed. There are lots of websites which actually show a map of every technologies and every hybrid system integrated into the world. So I can give you some information about this. Regarding the tool and these applications onto this building, it hasn't been demonstrated, which means that the selection they've done, you're not sure they are optimal.
Thank you.
Thank you.
Are there questions? If seems not to be the case, thank you once again for your presentation. We're coming now to the second presentation. It will be done by Wim Zeiler. He studied mechanical engineering at the Technical University in Twente in the Netherlands.